Well, welcome everybody, especially for coming out on this very nice dreary day. So thank you all for venturing out to our first in our Science for Community series. So we skipped a couple of series, but we're back, and we have a great lineup of 4 talks that I'll explain in a minute. So you're going to have a great private talk with our expert here, Dr. Dave Sequel. So again, welcome. This is the first of 4, and okay. So today you're going to hear all about one of our iconic fishes in the Chesapeake Bay, our striped bass, Dr. Dave Sequel. Next week, April 9th, Dr. Jenny Lesledge will be talking about another important species here in the Bay, the Atlantic menhaden. And then April 16th, Drs. Gonzier and Hayes are going to talk about a new initiative here called Anthropogenic Changes in Estuarine Ecosystems. And then finally, on April 23rd, Dr. Chris Rao is going to talk about biodiversity in the human era. So feel free to come back to all of these, invite your friends. I should point out this is hybrid. And so all of the leaflets that you see around, you're welcome here in person. We love to see you. But we understand the hybrid. So we have a number of people. You can't see them because this is they're in another room, but we have a number of people that have registered virtually. So if any of your friends want to join virtually, that is also an option. So I see a lot of faces that I recognize from docents or prior Science for Community series. So you all know we were founded in 1925. We are coming up for our 100-year celebration. That is incredibly exciting. We're the oldest state supported marine lab in on the US East Coast. So 100 years is a great achievement. And so, watch out, we'll be having some celebrations. I don't know what they're going to look like yet. We'll certainly have our open house again in the fall. So we are one of 6 constituent members of the University of Maryland Center for Environmental Science. And we are a world leader in science of coastal environments, their watersheds, and also in environmental education. So we have a strong standing 99 now year tradition of researching innovative solutions, both regional and global environmental problems. And we have here at CBL, our main foci are things like fishery science, biogeochemistry and toxicology, ecosystem studies, and restoration science. So our researchers, they gather, they analyze, and they interpret data to better understand our world, and a key part is to inform policy. That is something very unique about our institution. We don't just conduct fundamental research, hypothesis-driven research. We conduct applied research. We're addressing problems that state managers, agencies want solutions for. And so we have a very interdisciplinary applied program to provide those solutions to various stakeholders. So we make an impact not just here in Maryland, but nationally and also globally. We conduct a number of things relating to water quality. Our peer data has been conducting water quality analyses. Dr. Walter Boynton in the back there has done a lot of work in terms of the water quality monitoring and nitrogen pollution here, which is, of course, one of the Bay's biggest issues, nitrogen sediment pollution. We've also expanded and looked at things like septic tracers, providing advice to the state in, well, where are some of these pollutants coming from? And so our analytical chemists have designed a lot of analytical techniques to actually try to use what chemicals are in septics to try to tell you, well, what that pollution in the streams is coming from, that septic or that wastewater treatment. And as I mentioned, we provide advice to the state, region on sustainable fisheries and ecological stream restoration. And a lot of our researchers investigate the impacts and causes and implications of climate change. We have a number of we have a new initiative. This is the anthropogenic changes in estuarine systems. You'll hear about this in a couple of weeks from Dr. Gonzier and Hayes. This is being initiated thanks to a $1 million donation from Ryan Hockheimer and Marjorie Wax. I should point out, I learned how to use QR codes. So if you want any more information, you will see this as a continuing theme on every slide. You know, I've got a QR code. And so this has allowed the provision of state-of-the-art analytical equipment. This is really, it's expensive, but really novel equipment to allow us to study emerging contaminants. And we have a number of contaminants that may have impacts to environmental and human health. So that's what this new initiative is going to allow us to do. Another new initiative here is, and UMSI's wide, is our Chesapeake Global Collaboratory. Of course, as you're aware, we have a lot of environmental problems. And so the goal of the collaboratory is to look at these issues and try to accelerate the environmental solutions for them. And so this is bringing in diverse voices, multiple stakeholders, looking at novel approaches to questions, and also innovative tools to provide actionable solutions to a number of environmental problems. And the reason why I bring that up is because that is going to be housed. We're going to have a new building here. It's where the Northern property is, the blue building, right next to the Truett building over there. We're going to have the Chesapeake's Analytics Collaborative building, and that is a $22 million investment from the state, and that will be right here on our campus. So the one thing we love doing here is our community engagement, and you'll see we do a lot of local educational signage. The one here on the top right, if you've walked along the boardwalk, you'll see 3 of these. So these signs were developed in a plastic program. It was spearheaded by Dr. Helen Bailey, who's a professor here. And I was also on the project, but we provided these signs about plastics in the environment and what can you do to reduce it and what they are. We also have a middle school curricula, Way for Plastic. Our excellent science coordinator, Jessica McLinsey, is in the back there, and there's posters on that. And this is a really great curriculum that's in Calvert and St. Mary's. It's been in our school program for about 6 years now. It's also just been expanded to Charles County and Anne Arundel County. And as I mentioned, community members, they work with us as well. I mean, they've allowed our scientists to go and sample their septic systems, to be able to allow them to be able to come up with these analytical methods to be able to trace septic chemicals in the environment. We also do a lot of outreach events, like this Science for Community series that will happen every spring and fall. And talking of the signage, you've driven past, this is our Solomon's Climate. This is using data that is from up here. This speaks to the importance of our long-term data sets. The data that was collected on the pier, the water temperature there, this is the actual data plotted from like the 40s all the way up to recent times. And it just clearly is a clear visualization of climate change. So the blue are the colder temperatures, the red are the warmer temperatures. It's a really easy vision to see that. We also have right by the roundabout a sign on bay grasses as well. The other thing to point out is our Dolphin Watch program. There's leaflets and also a poster at the back. And that has been a highly successful community science project, and it's in its 7th year. There's the QR codes, there's a phone app. And so any of you are out on the water, then you can log, this is what it looks like, log a dolphin sighting. This is really, really important for us. We have new sightings, that we found that because of this app, they've been found dolphins much further north in the bay than they've seen before. So it allows us to look at the changes in where the dolphins are and the numbers of the dolphins in the bay. And of course, we have our open house. We brought that back. Unfortunately, for those of you who might have attended, and for those of us working it was pouring it down. And so we still had over 500 visitors that braced the rain. It was pretty driving rain for most of the time. This is our interim president, Bill Dennison, driving the ROV. That's a very good demonstration. It's Dr. Laura Lapham's lab here. And so you drive this ROV, pick up things, and so that's a great activity. And then also, this is Dr. Dave Secor's lab, the Tailwinds project, in terms of looking at the potential impacts of offshore wind development that's happening on Ocean City. So just a heads up, we will be having an open house coming back in the fall. The other thing we're also proud of is our environmental education. So we're part of the MEES program. We also have other collaborations with other institutions as well. But we have a really innovative graduate curriculum. We have very interdisciplinary foundations, and our students actually solve very important real-world problems. They've all gone on to successful careers in both the private sector, the government, in NGOs and academia. And of course, this is my end slide. I can't finish this talk without a pitch. So you'll see there's some like little leaflets. Donations to our graduate students are incredibly important to them. It supports their research. It also supports them to be able to go to national and international conferences where, of course, they make connections they might not have made before, that really benefits not just their research program, but their overall professional development and career. So please feel, if you can, please feel free to support our graduate students. But with that, I would like to turn it over to our speaker this evening. Dr. Dave Secor is one of our fisheries scientists and globally renowned for his area of expertise in fisheries, particularly migration ecology of fisheries. And I'm not going to say too much because he's going to tell you all about some of his stuff, but looking at fisheries and protected species, and then more recently, this offshore wind impact assessment. So with that, thank you all for coming, and I'll turn it over to you, Dave.
Thanks for being here. You enable editing? No, you got it.
That's it.
Okay, thank you. Thank you for that nice introduction, Karis. Can everybody hear me if I get away from the mic a little bit? Yes, great. So you were expecting a much younger face than mine.
Oh, I should have pointed it.
I'm sorry that Professor Wilberg couldn't be here to discuss the most important fish, I guess, which is striped bass. This is me in '94, newly minted assistant professor here at CBL. And really, I've been having a 30-year conversation with all of you as stakeholders, fishermen, and it's always been striped bass. Man, how much more can I say about striped bass? I mean, it must be the most important fish. I mean, why do we keep talking about it? So anyway, I appreciate your interest. So I actually talked about it 2 years ago to this group during COVID. And that was, of course, from my home office. It was kind of strange. I wanted to be upbeat. So I said, you know, striped bass, they've got problems, but man, this fish is really resilient. They always bounce back. That was a big message. Even though we kind of love them a little bit too much. We're too enamored by those stripes. We like to eat them. We like to catch them. But they hold their own. Well, not so much anymore. I'm afraid the story I have to tell you today is not a real cheery one. All right, so one of the things that's happened with striped bass is they've become now rather the poster child of climate change. That they are kind of the first fishery that's actually been closed because of climate change. That conditions in the summer have become too warm for them. Virginia has closed their summer fishery. Potomac River Fisheries Commission has closed most of the summer to fishing. And Maryland DNR has a regulation that's based on air temperature, and it results in most of the summer time being closed to striped bass fishery. It's just getting too warm for them. And I think this is something that we don't recognize. So I got together with the executive director, Potomac River Fisheries Commission, Marty Carey, and we wrote an essay to the Bay Journal about this, what was going on. And we said that the anglers are facing a stark future in which summertime fishing for striped bass once a hallmark. You can think of Wilberg, you can think about the families. The emergence of recreational fishing that really happened in the 60s and 70s. Certainly we were angry before that, but now everybody's in. Just a big surge in interest in striped bass in the 60s and 70s. And it was in the summer. That's gone. That's gone. It's becoming an ever distant memory. That's pretty depressing. What's going on in the summer is basically the striped bass are cold-blooded, they're poikilotherms. You heat up the water, and their heartbeat has to go up, their respiration has to go up, their metabolism has to go up. It's harder for striped bass to make a living. They've got to go find food, they've got to feed their basal metabolism. They don't even get to grow. And as they hit this summer period, which has always been there, it's always been stressful for striped bass, but now it's all more stressful. The other thing that's happened is that we have a disease that is systemic in the Chesapeake Bay, mycobacteriosis, and this disease now infects most striped bass. So it's always there, but because striped bass are resilient, water cools, they start feeding, they recover from it. This is not a one-way trip for striped bass, and I know this. I've held striped bass with this disease in tanks and feed them, treat them nicely, they recover. Even when they have ulcerations like that, they can recover. So if we take a day in the summer life of Moronis saxatilis, sounds a little bit like a story I once read. Let's look at it from the angler's point of view. They go out in June, they catch a fish, and the fish is just a little bit undersized. And they release it carefully. And from the fish's point of view, they've just had a belly full of silver sides, it's kind of cool still. They're feeling okay. And they said, oh, I can handle this stress being caught. I can recoat this lactic acid buildup that I had during the fight, and I can recover and stand out. Now we advance it a month, and the angler now catches this striped bass. It's now a size that angler can keep, but he looks. But she looks and she sees some spots along the flank. Nobody wants to eat a diseased striped bass. Back in it goes. From the fish's point of view, now it's saying, oh man, now I have to fight disease. I continue to elevate my metabolism, expire really fast, and now I have no extra energy really to recover from this fight. It's going to take me most of the day to recover from being caught and released. Now we advance into August, and the fish is in really bad shape. Has ulcerations. It is devoting all its energy just to keep pace with what's going on in its life. It's caught, obviously, with these kinds of ulcerations, it's released, and it's a doomed fish. It can't recover from that. Well, this is all kind of a terrible story I'm telling you. Is there any evidence for this? Yeah, there is. This is a VIM study done in the Rappahannock, a multi-year tagging study. And if you look at that plot, that red banded bar, that's striped bass that were tagged, that were severely infected. And then they looked at the probability that they were going to be caught by anglers again. And the probability is over 50%. Fish that had lower infection rates, half of that and less. So what's happening is the fish is fighting this disease, it's emaciated, it's hungry, it's going to go for a spoon, it's going to go for a lure, go for an easy meal. This is a very vicious cycle. The fish is diseased, it's caught, it's stressed, the disease progresses, it's more likely to be caught, it's released. So this is a one-way trip. And in fact, the VIM study showed that 9 out of 10 fish died during this. That's an incredible death rate. So regrettably, this kind of heat trap, the only thing we can't do anything about the temperature, we can't do anything about disease, we can't pull fishing out of the equation. And that's what management agencies have been doing. I see Karis with the same frown. Sorry, but all right. Sorry about all that. I'm going to start you off with a striped bass. Maybe it's not so bad. Maybe this is just the Chesapeake during the summer. What about annual catches? Striped bass are coast-wide. They're migrating up and down the coast. The ocean's nice, kind of clean environment. Maybe we don't have these issues. We don't see disease too much in the ocean environment. So is this problem just limited to Chesapeake? How important is fishing? compared to other kinds of stresses like disease elsewhere? And what are some of our solutions in the shorter term and longer term? Now, if I was the designated speaker, I would have taken a very different tack on this. Professor Wilberg would have talked about all these same kinds of issues, but he would have taken a very different approach, probably a smarter approach. And he and his student, Samara, they would have talked about modeling. And modeling is great because what it does is it allows you to take the best information and develop your best understanding of how striped bass operate in the Chesapeake, how they operate in the Atlantic, how the fisheries operate in the Atlantic and the Chesapeake. And there's some things that might be uncertain, but you can challenge those things. You develop scenarios and see if those uncertain things matter or not. So you can construct worlds within worlds within worlds. That's a wonderful thing. And then you can, if you develop a model that's realistic and feasible, you can take that model and you can start saying, well, what if we do this? What if we have these kinds of regulations? What if climate change moves in this direction? And so this is the approach that Professor Wilberg and his PhD student are taking right now. It's a very productive one. And I think maybe this is where the most important fish comment may have come from. That whether it's the most important fish, it's the most important fish deserving an assessment model. For all these years, we've never had an assessment model specific to the Chesapeake Bay. And this is what Mike is trying to do. The assessment model that guides management for striped bass is coastwide. We just lump everything. And here he's trying to disarticulate it. All right, but I'm not Professor Wilberg. So you're going to get a lot of empiricals. So I'm going to break this apart into some ecological questions. And I've already talked to you about the resident part, the resident striped bass. These tend to be fish that are, say, under 30 inches. They stay in the Chesapeake. And I've told you that there's a warming problem, there's a mortality problem. The next bit is they can escape all this. If they get to a decent size, 30 inches or so, they can go on the Atlantic. And then they don't have these kinds of issues. Except they do still have a bit of a fishing problem. We're going to talk about that. They're still heavily exploited off areas like New England. And then the last bit is the vulnerable part, which is the earliest stages. And we'll end up with that. The gold standard for managing striped bass is called spawning stock biomass. Basically, what that means is we want to have a lot of big, fat, healthy females in our population because they produce the eggs, they produce the reproduction. And if they're the store of what gives us our future fishery. They're the bank. Now, the blue filled area, that's our spawning stock biomass. And you can see we're a bit in a hole before I arrived in the 80s. They call that an emergency. We're in such bad shape in terms of spawning stock biomass. We did the right thing. We ratcheted down fishing and look at the explosive recovery. This is a worldwide kind of success story. Everybody talks about the success of what we did with striped bass worldwide. We get up, and then that dash line, that's actually kind of like our target. That's where we want to be, given the best world scenario. We actually achieved our target, which is kind of unusual for many fisheries. That means we're in a surplus. We're in a really, even with all our fisheries, we're doing really well. The solid line says our fisheries need us to be above that line. If we want to enjoy striped bass the way we are enjoying them in terms of recreational fisheries, commercial, we got to keep spawning stock biomass. We have to keep the bank stores above that line. If we go below that line, then we can't sustain our fisheries. We get into a situation called overfished. And we've been in that situation, unfortunately, since about 2014. And this data comes from Atlantic States Marine Fisheries Commission, compact of states, and you can get on the web and find it for yourself if you're interested. All right, what are we taking from this population coastline? All right, we weren't taking much when there wasn't much out there in the 80s. And the other interesting thing here is the red line is the commercial fishery. Commercial fishery used to get a much bigger piece of the pie than they do now. Now it's fairly minimal. So the bars are indicating the millions of fish that we catch or that we kill through catch. Everything you see pretty much is dominated by recreational fishing, all those blues. So this is a recreational fishing problem if we're overfishing. And it's not just that, is that the biggest source of mortality is release mortality. And that's really strange. That's very strange when you think about it. We're catching a fish and we're releasing it. Isn't that a good thing? It seems like that would be a good ethic to have. We want to keep those big females. So let's release our fish so they can grow into big females and support the population. Well, the problem is that we love striped bass too much. And we're bringing too many fish to the boat and releasing them. And even if we are careful, we're going to have loss of some of those fish. The current estimate is about 9% of those fish released die. So the problem is that we're bringing too many to the boat and releasing them for each one that we keep as recreational animals. And this figure shows that. This is the number of released fish divided by the kept number. So each one we keep. If we look at Maryland, it's about 5 to 7. We bring 5 to 7 fish to the boat and we keep one. That seems kind of high, but it's astronomical when we go into Massachusetts and New England. We're bringing in 60 or more fish for each one. That seems ridiculous, doesn't it? It seems very wasteful. But I double checked this with my colleague at Massachusetts DMF, who's now leading recreational fisheries division. He says, yeah, it's probably higher still. So we'll talk about why this happens, but it is clearly the biggest problem right now in terms of ocean mortality for Atlantic striped bass. And all this data comes from NOAA's MREP Recreational Atlantic Site. All right, so we have this problem in the Atlantic, and it's going to be somehow connected to Chesapeake. The Chesapeake fish go to the Atlantic, and actually they support most of the fish in the Atlantic. There's some recent genetic data that says that the coastal stock of Atlantic striped bass are about 80% Chesapeake Bay origin. So they're spawning in the Hudson, they're spawning in the Delaware, but most of it's, even in recent times, coming from the Chesapeake. I would have suspected not because of some of the issues we're seeing in the Chesapeake, but the Hudson is actually the one that's declining in this period of time. All right, so this is old stuff. I probably, for the regulars, I've shown this before. This is tagging work I did in 2014. I think I have my prop somewhere. Here it is. These are acoustic pingers. We surgically implant these in striped bass. In the Potomac River, we implanted 100 striped bass with these pingers. We let them go. We put out these little telemetry receivers on buoys and different ways we put them out. That's in the duct tape thing that I'm holding up there. We put them in the Potomac, we put them in the Chesapeake. This is a system easy pass, the striped bass with the pinger swings by. If the receiver is sitting about 500, 800 meters distant, we can pick it up. The pinger is coded, so we can relate that to information about the fish when we tag it, whether it's a male or female, size, that kind of thing. So that's that. These are the size ranges. So we can tag a good diverse bunch of ages and lengths in the study. We had receivers to listen for striped bass, not only in the Chesapeake here, but also colleagues of ours. Some of these are ours off Ocean City, part of our offshore wind work, but colleagues of ours also have them in Massachusetts, New England, on New York Bight. So this gives us a real opportunity to see how striped bass that we tag in the Potomac River move to coastal areas. Does everybody track that okay? It's a tagging study, but the fish are telling their own story. All right, so the first thing we wanted to know was what size do they leave the Chesapeake Bay? And so if we heard these fish anywhere in coastal waters, we gave them a 1. We said, yep, they're coastal fish. If we didn't hear them, we gave them a 0. There's no in between. They're either in the Chesapeake or they're outside the Chesapeake. And when we did that, we got this kind of surprising result just because it's so clean. They're always in the Chesapeake Bay until they're 80 centimeters, about 30 inches. And then suddenly they migrate. They go out into coastal waters. That's pretty remarkable. I would think it'd be a little sloppy. But no, that's kind of the way it is for this group that we tagged. And as I mentioned, these fish leave and they're contributing 80% to that coastal fishery. They're also connected as shown here. This shows day of year, so 100 I think is kind of the end of May. And so we tag fishing way up there in 2014 in the Chesapeake Bay. And within weeks, they're up off Massachusetts. So they really book Chesapeake Bay. And you can see they spend Massachusetts a long time up there, months, summer months into fall, and then they migrate back south. And they do that. These are 5-year tags. They do that year after year, just like birds. Isn't that cool? Seasonal migrations. I just love this graph. In any case, the dark ones are the big fish. They're the ones bigger than 30 inches. The gray ones are the smaller fish. But look what happens. We start seeing gray dots in our later years. What that is we tag fish below 30 inches. They grow, and they grow into bigger size classes. So this is further evidence that fish, that threshold holds, that these fish are growing into that migratory group as we progress in years. All right, so we talked about hook and release mortality last time, and it is definitely the biggest source of loss. Why does it occur? Well, first off, our size limits, as we're trying to regulate this, as we're trying to ratchet down fishing, they get ever smaller. So we use now slot limits. That means we have to catch fish between X inches and Y inches, and those can be 5, 6 inches. So we're having to target some striped bass that may be very difficult to catch. We can only keep the ones in that slot limit. That means we're catching a bunch and releasing them to keep that one in that slot. That's a big part of this. Historically, in some areas in Massachusetts, I don't want to point out that, but there is this idea, I want to catch the biggest striped bass out. And I have a krill limit, I can only catch 1 or 2 striped bass. So I'm just going to catch these fish and I'm going to release them until I get the biggest fish, or worse still, I'm going to keep a fish that's big until I get a bigger one. But that fish is not in good shape when you do that kind of thing. There are people who have the goal of catching 100 striped bass in a day. I mean, this is a thing. It's pretty, I don't like it, but it is a thing. And then unintended catch. You could be out for bluefish or black sea bass and catch this. I don't want it. So we need, because this is such an important issue, we don't have a lot of data on things like release mortality. Our data comes from New England waters. We need better information in Chesapeake Bay. Maryland DNR has done some nice studies, but we need more information. Yes. And so this is all from ASOC. There's a very strong mission to try to get better understand this release mortality. And here I'd like to advertise some research done by, it's led by a colleague of mine, I'm involved in it, Dr. Reed Nelson. He's a new assistant professor at George Mason University. And it's great to work with young scientists. And I'm very excited here at CDL that we're going to be bringing in a new fisheries ecologist. It's about time. We're not getting younger. I think I'm the youngest one. That's not good. Okay. So we're very excited about it. Anyway, in the meantime, it's great to interact with these young guys like Reed because he dives. Every once in a while, we lose one of these receivers. I don't dive, and he goes out and catches, goes and finds it. But what he has done is he instrumented the Patuxent River. Look at all these receivers. So striped bass, we put a tag striped bass in there, we're going to hear it many times. And so what we're going to do is we're going to tag striped bass. We're going to catch them, like simulate how we catch an angler catch them. We're going to do that in the next several weeks, and we're going to do it in summer, like a couple seasons. And we'll look at how those fish do in terms of mortality rates. But we can do that with these tags. We not just look at movements, but we can look at mortality rates as well. But if you use the method that I use, which is to take a nice little incision, drop it in, you could never separate the effect of that kind of tagging from release mortality. No reviewer would pass it. So we have to come up with another way of tagging these fish with these tags that allow us to track them all the time. So we're doing external attachment, which is much less stressful to fish. So we can attach a smaller one of these externally to the fish. And then that's going to have much less effect. and we can monitor the dominant effect of catching and releasing them. The other thing we're doing, that Reed is doing, which I really like, these are releasable tags. So he's done all these really perverse experiments in the lab with different levels of monofilament that's designed to break at 30, 60 days. Because it would not be a happy striped bass that had to carry around one of these the best. These eventually will come off. ASMSC, of course, they have to take immediate actions because we're in an overfished, bad news situation. And so Chesapeake, we have one fish limit, recreational fishing, that's lot limit, 19 to 24 inches. That's a 5-inch target. That's hard. That's harsh. Atlantic coast, one fish limit, 28 to 33 inch. Try to hit that. It's like a bullseye. That's hard, especially since those fish that I showed you there, that's about when they're migrating out. They're going to grow and then they're going to grow outside of that slot limit. So the commercial fisheries have to contribute to the recovery. And then we're going to look at this again, managers say, and if it's not enough, we're going to impose more regulations. This could be heading towards a moratorium situation. It's getting very, very stringent. And Maryland just yesterday posted this. They're canceling what was called the trophy season. This is to allow access to these big spawning adults. The idea is, why should Massachusetts coastal states just get access to big fish? And many years ago, Maryland, as the striped bass was recovering, Maryland developed this trophy season for the spawners. The idea was, as they're leaving, we were going to allow access for anglers to this. That's completely closed for the first time this year. All right, I'm going to skip that. And we're going to move to the next step, that basically, if we want to have recovery in this population, it's going to have to come on the backs of juveniles. We have to have good years of reproduction. And that's the stuff that goes up in the upper parts of our estuaries where we have spawning and nursery habitats. Maryland, for many decades now, it's stalwartly gone out and done this juvenile seining. So it's very, very important. It drives our understanding about recruitment juvenile, that how reproduction does year after year for the whole coastal stock. It's directly related. And what we depend on in most years, it's bad. It's bad for striped bass. The conditions just aren't right. Females come in and spawn, get larvae, and then something bad. We get a cold, everything dies. The zooplankton isn't right. We have all kinds of theories. Walter has his theories. I have my theories. Now there's a whole other generation of theories. It's to do with winter temperature and flow and snow conditions, all when the cherry blossoms bloom. I mean, it has all kinds of things out there that people have suggested. But basically, in most years, it's not going to be good. It's only those rare years, maybe once every 5, 10 years, where striped bass females and spawning neighbors hit it right, conditions right, and then it's explosive. And you can see those explosions. 89 isn't that explosive, this is juvenile abundance, but it was enough to generate that really strong recovery we saw in striped bass. 2015 was a recent good one. We've had a lot of hope for that one. We've had a couple more. 2017, 2018. But if you look at the last, 5 years? Big time, all really bad years. That doesn't happen very often. That does not happen. We have 4 years in serial periods of time. The last time it happened during this period. And this is when we enacted all these different emergencies. We had a ban on the fisheries, so we should be concerned about this. Now, this time, we had a big argument. We said, some people said, and Ron knows this one, some people said there's not enough spawners out there. And we had folks like Eileen Setzler Hamilton at this lab going to the Potomac River, and Walter, you could barely find a striped bass larva. That was pretty worrisome. So yeah, that could have been the case. And then there was another group that said pollution's a big problem. Back then it was acid rain. We knew there were metals that could be mobilized during acid rain. There are lab studies that showed that larvae would die. All the larvae would die if you had these kinds of conditions. And, my colleague Ed Hood and I, you looked at this in the field. So there was a lot of reasons that maybe habitat degradation could have been, pollution could have been contributing to this situation. But a model got us out of this trap. We were arguing back and forth, and nothing was getting done. A modeler like Professor Wilberg got us out. That's what models are great for. He said the degree of effect from having too few spawners because you're overfishing or having habitat degradation are the same in the population. We can't do anything about habitat degradation. We can do something about fishing. And his point on that was Professor Dr. Phil Goodyear, who proposed that, and it was accepted. And that brought about those really stringent fishing regulations there in the recovery. Is that going to save us this time? I'm going to say no. I'm going to say no. My colleague, Dr. Jim Uphoff, might disagree with me. Jim has a really great, important statement about what's going on with habitat degradation now. That we are hitting in our coastal counties thresholds of impervious surface that we haven't hit before. And this is having direct influences on our natural species. That's a very important statement. I just don't expect that we have this threshold yet. I do think that blue catfish were introduced in the 1990s. They kind of held in Virginia waters. It's a trophy fishery. They kind of stayed in Virginia and upriver areas. And then in the 2000s, they just erupted all over Chesapeake. They decided they liked brackish water. Yeah, that there are now our most abundant fish-eating fish. Striped bass are rare compared to blue catfish in today's Chesapeake Bay. They're just, you can't avoid them. So this is a river that I'm working in to look at sturgeon. It's the Marshy Hope Creek, a major tributary of the Manicoke. And we're using side scan sonar to image sturgeon. But in the meantime, we're imaging smaller things on the order of like 20 to 30 inches. All those little yellow dots. We think those are blue catfish. We're pretty sure.
What do you want to search for?
Blue catfish. So anyway, because we trawl, we get blue catfish. But in any case, if we extrapolate that out, you see we have measures 20 meters. So I get one fish per 30 square meters, 120 fish per acre. And if we extrapolate that to the whole Marshy Hope Creek, we get 1 million blue catfish of decent size. That has a tremendous consumption demand. In the James River, they've estimated the consumption demand. Similarly dense blue catfish, 5 metric tons of striped bass using genetic techniques. By analysis. These are smaller striped bass. You're not going to be feeding on you're feeding on little 2-inch fingerlings, maybe larvae and eggs. And so I did the calculation. They were 2-inch fingerlings. It would be over 3 million fingerlings. So I've done some abundance estimates of juveniles. When striped bass weren't quite as abundant. We're talking about hundreds of thousands, maybe a couple of million. So this is clearly could be a dominant influence. What could be happening, because blue catfish are opportunistic feeders, is that we could be having stronger classes of striped bass. Opportunistic feeders feed on the things that are more abundant. So striped bass become abundant, they crop them down until they're less abundant. And I think this is why we're kind of getting this steady recruitment level that's low. At some level, blue catfish say, okay, I'm going to move to the next abundant. So that's not, this is really crazy. My DNR colleagues at Marshy Hope Creek, they saw blue catfish coming up during the spawning period for striped bass. Striped bass splash at the surface. You could tell when they're spawning. So they saw some blue catfish and they trained in this activity. And they thought maybe they were doing something they shouldn't have been doing. And they pulled the blue cat, they opened up the guts, and they're full of striped bass. So this has to be a learned behavior. They're taking advantage of that bit of concentrated eggs in the water column. All right, so wrapping up, this is kind of Marty Gary's and my conclusion is basically we have to shift our thinking about recreational fishing in Chesapeake Bay. It's very sad that if we want to protect striped bass, we're going to have to start fishing on the most abundant ice of water. Blue catfish. Blue catfish are good to eat. And in our mind, we should know that every blue catfish we remove from the Chesapeake Bay is doing our native fishes a big favor. The charter boat industry, you can imagine, is in really bad shape right now. They just shut down the trophy fishery. They made their money in the trophy fishery, in the 6-packs that go out in the fall and spring. They can't find striped bass like they used to. I think they're going to have to reorganize and make lemonade out of lemons and focus on blue catfish. Okay, well, thank you.